So, Coulomb's law. This law is the basic of all the things which we are going to study about electrostatics. So, let us see what is Coulomb's law. A scientist named as Coulomb has stated a law and which defines the force between two charged particles like this. The force F between the two charged particles will be equal to Q1 Q2 by R square multiplied by a constant. But the actual law that is stated by him was something like this. Force is directly proportional to the multiplication of the charges, whereas the force between these two particles will be directly inversely proportional to the square of the distance between them. For example, these two are the charges and the distance between these two charges will be R, and the value of this constant K is given by K is equal to 1 by 4 pi epsilon naught, that will be equal to 9 into 10 to the power 9 Newton meter square per Coulomb square. So this is the value of the constant of this equation. So finally, what we are going to infer from these equations and all, from this mathematics, which we are what is the thing which we are going to infer? That means, see, for example, and the main thing which we have to remember about this thing is force is a vector, that is F bar, whereas this thing is only the magnitude. We have talked about magnitude only till now. So for now I am talking about the direction of the force also. F bar is equal to K into Q1 Q2 by R square A R cap. So A R cap is the unit vector along the line joining these two charges. So let us look into this clearly using this thing. Let us consider three different scenarios. Let us consider three different scenarios where this is a negative charge and this is a negative charge. This is Q1 and this is Q2. As I have said earlier, these two are negative charges, so automatically Q1 will be negative, Q2 will be negative. Multiplication of these two will be positive, so automatically the force between these two charges is positive, and these two forces repel each other and they try to move apart from each other. Similar to this, if you come to this case where two positive charges of Q1 and Q2 are placed side by side, so automatically, similar to the thing which we have done earlier, Q1 is positive and Q2 is positive, so automatically F value will be positive value. So these two charges try to repel each other depending upon their charges. Now, let's consider the third case where a positive charge Q1 and a negative charge Q2 are placed side by side. So automatically this is a positive charge and this is a negative charge. As this is Q1 is positive charge and this is negative charge. Multiplication of the positive number and negative number will result in a negative number. So the force between these two particles is negative, which means that they will attract each other and they try to move towards each other like this. This is what the Coulomb's law tells us about the magnitude of the force between these two and also the direction of the force between these two. Let us consider a simple example where Q1 and Q2 are like this. So automatically, as we know, F is directly proportional to Q1 Q2 by R square. What if I make this Q2 larger? What will happen? If I make Q2 larger, automatically this product will become larger, making this F to increase. So automatically, as the amount of charges, as the magnitude of the charges increase, automatically the force between these two will also increase. The force may be repulsive or attractive depending upon the types of charges, whether they are positive, whether they are both negative, or one of them are positive or one of them are negative. This is how we can discuss about Coulomb's law.